The language that a person speaks forms an essential part of his or her identity. The manner in which someone speaks can vary from person to person, and with it, the meaning of what is communicated can change dramatically. The same applies to how a person writes. Sometimes the way in which a person writes is different from the way in which he or she speaks, and this is also an identity. The brain of human beings is able to process all this and is able to form an opinion about a person with a combination of his speech, his writings, and his activities. Artificial intelligence can be field in computer science that is trying to mimic the human brain, and there are a lot of subfields under it. Natural language processing is the subfield which deals with understanding the human language and building applications around it so that we can benefit from the same. Hello and welcome to the video series on natural language processing. In this video, we are going to begin by seeing an overview of what natural language processing is, the associated terminology, a high-level view of the components that make up natural language processing, and conclude by having an overview on a sequence of steps that can make natural language processing possible for artificial intelligence. Natural language processing as a technology is built on several layers. It begins with the science of linguistics. This science of languages is applied to computer science, in which artificial intelligence is already a field. Natural language processing is a subfield of artificial intelligence that takes in the knowledge of all these bases and makes it into a technology that helps the artificial intelligence understand human language and respond to the same. In doing so, there are obviously two types of processing involved. One is the response to textual input. The other is the response to vocal input. Like you would have already used or interacted with some of these applications. If you are someone who is using a digital assistant on your phone like Siri, you are interacting with a voice-based artificial intelligence. And most of you would have interacted with chatbots when you are trying to contact a help desk or similar entity. So there the text-based processing comes into effect. We will now look at four terms associated with this field. The first term is called as natural language understanding. What this involves is just understanding what is being said, literally. When I say apples and mangoes, the person hearing or reading it must be able to recognize that what is being said or written is apples and mangoes. Mind you, I am just talking first about understanding the word, knowing the meaning behind it and recognizing what it is comes later. The next term we will see is natural language generation. As the name indicates, this involves generating words or sentences which are meaningful and can be used as a response to a query. Then we have natural language recognition. This involves several aspects like named entity recognition, speech recognition. We will see about these later in the course. In short, this involves the intelligence being able to recognize key factors in a word or a sentence and be able to use it for further processing. Then what we have is called as natural language synthesis. This is something some of you would be using already. You have many text-to-speech engines where the system would read out loud what is on the screen. It could be a news article or a short paragraph. So this is a useful application when instead of reading, you can hear out what is on the screen. This could also be useful in cases, say, where there is a storybook which you do not want to read but want to hear. You could apply a text-to-speech engine to understand what is in the book and read it out to you for you to listen. There are several components in natural language processing that have been listed here. Syntax analysis involves analyzing the structure and format of a sentence and identifying the purpose of the words. Morphology involves understanding the structure of the words and their pronunciation. Part of speech tagging involves the grammatical groups, identifying the subject, verbs in a sentence. Then we have term extraction, where you identify the key words in a sentence to get the meaning properly. Semantics basically involve understanding a complete sentence with its proper meaning. And then lexical analysis involves understanding in a context. As you know, in English or any other language, where a sentence is or a word is and its meaning completely depends on the context. For example, consider a scenario where you are talking to a friend in another country. He is thinking of visiting you at your place in 2 months from now. He may ask a question, how's the weather going to be in 2 months from now? As you can see, there is no fixed answer to this question. You need to know the context, like what is the current date, what is 2 months from now. At that point, in the geographical location that you are in, what is the weather, and you will have to frame a response. So this is where context becomes important. The place at which a question is asked, the time at which a question is asked, and based on that, the answer could be completely different. What could be an answer in the month of April for someone visiting you in July would be completely different when the same question is asked in the month of October. This is just one example of context, and here is where the language processing entity must be able to correlate a lot of things before giving a response. A human brain does this automatically, but if an artificial intelligence has to do it, all of this context information must also be made to be understood by it for it to give a proper response. Then we have named entity recognition. To understand this, take the sentence, the cat is sitting on the wall, for example. Here, the named entity is the cat, and the sentence is about the action which named entity is doing. So like this, identifying the named entity is an important step to know what is being talked about. Then we have steps like understanding the meaning of the sentence as a whole. Then we have translation to convert from one form to another. We have discourse and discourse analysis, which involves identifying the interaction between various sentences, say in a paragraph. Then finally, we have the process called as automated summary. As you know, human beings are well capable of reading a long paragraph or a news article and summarizing it into a short 3 or 4 sentences to be able to convey the crux of what was said. This is a useful step which the intelligence can be used to help humans when a large amount of information has to be processed and has to be conveyed for the human beings to understand it in a short time. We will now look at a sequence of steps that can happen when an intelligence which is capable of natural language processing receives an input and works on it and gives back the output. The first step is the trigger. For voice-based action, this could be like OK Google or any key phrase which the voice assistant can use as the trigger to start processing whatever is being said after that. For text-based action, this could be someone typing a simple question or hi, hello, whatever. The first action initiated by the person interacting with the intelligence capable of natural language processing. The next step is called cleaning. This involves removing all the unnecessary noise from the input received. so that the received data can be converted into a format which is ready for the next step. In the next slide, we will take a deeper look at this cleaning step to see what are the sub procedures involved and why this helps in natural language processing. Step is called quantification. This step involves converting the data into suitable mathematical formats so that algorithms which make use of mathematical functions to reach at an output can be applied to it. The fourth step involves matching. We have quantified the data and we can apply mathematical functions to arrive at a result which can be compared against predetermined sequences computed and available as a data set, so to give a response. This could be useful when you are talking to a QA bot and ask for a specific question. Let us assume you are asking for holidays in your company and your company has a chatbot which can answer common questions from employees on HR policies and tools. This would be useful in arriving at a set of relevant matches from which a suitable response can be chosen in the next step. The penultimate step involves selecting the exact response that is going to be provided back to the person who raised the query. Here, the decision can be based on different factors. Uh, the step 4 would have resulted in 5 to 6 matches. And in step 5, there could be further intelligence and algorithms that could be applied, which will result in the final choice of the response that will be rendered back. A simple example could be that step 4 would have resulted in a list of holidays for different areas in a country, and step 5 could involve selecting the holiday list based on the location of the employee. Say if you are in India and if you are from South India, the holiday list of the South would definitely vary from the holiday list of the North. But your question would not have generically asked holiday list for South India. You could have just asked, can you give me the holiday list for this year? While step 4 would result in the list of all holidays, step 5 could be the step where the exact holiday list based on the employee's home location would be selected. This is just one example. Of course, many more complex actions can be done in this step. We will look at them later in the series. The final step involves providing the actual response to the person interacting with the intelligence. This step will involve some minor friendly interactions like appending the name of the person to the response and other small customization which would make the person interacting feel like he is interacting with a real human being rather than a chatbot. The final topic that we will be seeing is the process of cleaning. This involves 3 sub-steps, namely tokenizing, normalizing, and stemming. Tokenization involves identifying every word in the input that is received and having the meaning of that known. We could call this as a divide and conquer strategy where we have broken down a long input into smaller inputs so that we can work on them to further proceed with the processing. The next step is called normalization, or the step in which the data is converted into a form of uniform representation. Why do we need this? Take for example the date. The way in which a date is communicated is different in different parts of the world. Some people say the month first and the day and then the year. Say it can be 26/20/20 or 6/20/2020, or it can be June the 6th 2020. So like this, even though the meaning is same, the way in which it is communicated is completely random. And for algorithms to work properly, having so much randomness is not efficient. So this step will look at the tokenized input and convert it into a uniform representation. The choice could be to convert any date into a year, month, day, hour, minute, second format, so that in the next step where we have to apply maybe mathematical functions on it, that step can be written with the assumption that it will always be in the standard format. Say if the quantification step, which is the next step of cleaning, will use dates in year, month, day format, this is the step that is going to get it ready for it. The next sub-process in cleaning is called stemming. This step involves converting words into their fundamental format. For example, if you take the sentence, Virat Kohli is playing in his 100th match. Here, is playing is a verb which is in a continuous form, present continuous tense, where the fundamental form of the verb is play. This step will involve identifying such fundamental formats so that the data is ready for the next step where algorithms can choose to act on these fundamental forms and make whatever decisions based on the application for which the intelligence exists. So as a whole, the cleaning step involves getting the data ready into a format so that quantification actions can be applied on the available input and a suitable response can be generated in the subsequent steps. With that, we come to the end of this first video. In the subsequent videos, we will delve further into this topic of natural language processing, looking into further details on the components that we saw at a high level today. We will then start practical demos with the natural language toolkit that is available in Python. We will then look at the details about the algorithms that support natural language processing. Thank you for listening now. Looking forward to having you back for the subsequent videos. Bye-bye.